Hello, this is Britt Caswell with another example video. In this video, I'm covering example 1 from section 2-5 in the SavvasRealize Algebra 2 textbook. So in this example, we are using square roots to help us to solve quadratic equations. Now this is a kind of interesting type of problem because on this example, all of their sub-examples involve using what's called a perfect square trinomial. So a perfect square trinomial is one in which it's written in this form. It says a squared plus or minus 2ab plus b squared. Now when I say plus or minus here, I'm talking about two separate equations. But understand it can be a positive or it can be a negative. It depends on this first part. So if this says a plus b, this will be a plus. And if it says a minus b, this will be a minus. But this here is the formula. So notice that there's a 2 here and that b is squared here. My a value on this situation is 1, so it doesn't really matter. So what I usually do is I look kind of for a pattern. First I check to see that this middle number is even, which it is, and you divide that by 2. So 14 divided by 2 is 7x. Okay? And then I take the square roots of the outside parts. So the square root of x squared is x, and the square root of 49 is 7. And I say, well, is x times 7 equal to that 7x, that kind of target number that I set? Yes, it is. So this is a perfect square trinomial, so I could just bring this first sign down and square it, and that's how you factor it. Now this method is really nice in terms of a way to factor, especially if there's a number in front of x squared. It's really hard to recognize perfect square trinomials. That being said, you can factor that using the double bubble method and you'll get the same thing. Okay, so now that we have factored it, now we're going to go about the process of solving it. So right here I have a value being squared. So to get rid of a square, you have to take the square root. And don't forget, you have to put the plus or minus symbol in front of the constant when you square root, or else Miss Caswell gets very angry. Alright, so here I have plus or minus, the square root of 25 is 5. And on my right hand side, the square and the square root cancel out, leaving me with x plus 7. Now we need to get x alone, right? So to isolate it, I'm going to subtract 7 from each side. So here I get negative 7 plus or minus 5 equals x. Now we're normally looking just for two numbers, right? So we need to split this apart now. Okay, the first instance is when it's a plus, so I get 7 plus 5 is x. And the second instance is when it's a minus, so I get negative 7 minus 5 equals x. So that's negative 12. And here this is negative 2. So let's try another one. So my target number, this is even, so 12x divided by 2 is 6x. That's what I'm looking for. The other thing I look for is to make sure that this is a perfect square, right? Because we are taking the square root of it, and I'm getting 6. I'm taking a square root of x squared and getting x. So is x times 6 equal to 6x? Yes, it is. So I drop this first sign down, put parentheses, and call it squared. So now that we have factored it, Now we're going to solve it. So to get rid of the square, I'm going to take the square root of both sides, remembering to put my plus or minus sign so that Miss Caswell doesn't get mad. Now the square root of 81, that's 9. And then here on the right hand side, the square and the square root cancel out, leaving me with x plus 6. So then to isolate x, I'm going to subtract 6 from each side. And so I'm going to just go ahead and do the split right away instead of just rewriting it all. So I get negative 6 plus 9 equals x. And I get negative 6 minus 9 equals x. So this left-hand equation gives me a 3. And this right-hand equation gives me a negative 15. And remember, if I wanted to check my work, I can plug these back into the original equation and see if it works. Alright, so it's always a good practice to kind of check yourself before you wreck yourself, if you know what I'm saying. So here we go, my middle term, I have a negative 16x. We're not going to worry about the negative part. So I'm going to divide it by 2. That gives me 8x as my target number. So the square root of x squared is x. The square root of 64 is 8. So is x times 8, 8x? Yes, it is. So now that first sign is going to fall down. So now that we have it factored, now we're going to go ahead and solve. So to get rid of the square, we take the square root of each side, putting our plus or minus. Now the square root of 9 is 3. And then here, the square and the radical cancel out, leaving me with x minus 8. So then I'm going to add 8 to each side. And then because of the plus or minus, we're going to split into two equations. So I'm going to have 8 plus 3 equals x, and 8 minus 3 equals x. So for the first part, I get 11, and for the second part, I get 5. So there you have it. That is how we find the solutions to equations that have perfect square trinomials in them. Until next time.